So now, what is on our agenda? Number 2 is, so we're going to set up Redis on a Docker container. What happened here? On a Docker container. I found this article thing that helps us do it. So let me get everything set up over here on my other screen. All right. So first thing you need to do is, well, I can walk some folks through here if you're watching this maybe on YouTube later on how to get started with this, but you need to run some commands. You need to pull the Redis image. So go to CMD. Let's make this bigger. 1 second here. So we're going to do Docker pull Redis. Okay, so I pulled it earlier today, so obviously it's already good to go. So make sure you've done that or else this isn't going to work. And then we can follow the rest of this. So we need to actually start a container now. Let me find what the command is. All right, so we're running a new container, port 6369, and we're calling it Redis 1, and it's a Redis instance. Pressing enter now. All right, and if we just do Docker PS now, we should see. Well, if the format was a little bit nicer, you could be able to see this nicely. But we can see here that we have our Redis image running now. And now if I go to my Docker guy over here, it should show us the container is at least getting set up. Where is it? There it is. Okay, so it's running port 6369. Where is... There we go. This is kind of cool. You can see the logs for this too. It's pretty nice. I'm kind of a noob to Docker, so I'm just kind of nerding out over this. Probably going to do another Learn With Me session about Docker, actually. Anyways, so now we have this instance up and running, so that's good. Now we can actually connect to it. So I was playing with this a little earlier. Actually, I want to launch the CLI. Let's do that. Actually, let's do a couple more things first. So now we do Docker PS, right? And that's showing us that the instance is up and running. That's good. Docker logs Redis 1. It shows us the logs. We saw this in the console just a moment ago in the Docker window. Okay, now we can actually run the shell inside here. So we can say Docker exec it Redis 1. All right, so now we're in the Redis shell. So we should be able to do like set foo bar. Ooh, what happened? Oh, is it? Oh, okay. Sorry, I thought it was capital. I guess it's case sensitive. So get foo should give us bar. What? Meh. Oh, weird. Okay, so no quotes. So set foo bar get foo. What? Hold on a second here, boys. This is not working. Okay, hold on. Something failed here. Yeah. I'm a fool. Wait, we need to run this script. Okay, now we need to execute the CLI. There we go. Okay. So now we can ping the server. We're good. Let's do like set now. Whoa. That's pretty cool autocomplete. Look at that stuff. That's sweet. Okay, now we're talking. There were some technical difficulties there. Okay, so set foobar, get foobar, everything's good, right? Now, so I'm using the library Jedis for this. This is the recommended Java library for interacting with Redis. So it's the one that I downloaded. It's just through Maven. Here's my pom.xml, just Redis clients library. The artifact is Jedis, and I'm using version 3.2.0. So we're going to walk through a bunch of commands here and just like kind of screw with this for a little while. I'm actually going to follow a tutorial here on the side. Let's get rid of projects. And then we can kind of see this in action. But let's just verify that this is actually working first. So let's say set this to Baz and 1, right? And let's say Baz. So this should output 1 if everything is set up. Oh, to God it is. Okay, good. Now, I wonder if I try to get Baz now over here in the CLI, will this work? Oh, cool. Okay. So it's shared across both. So it's the same instance. Oh, I guess that makes sense why it would work. It's the same instance that you're interacting with. Here is just through the CLI. Here is through this Java program. Anyways, so we're going to do a quick little tutorial here. We can go through the thing together. Just kind of see what he's talking about, because I thought it was pretty good. If you guys know Baildung, he makes some really good tutorials for all sorts of stuff. But that's what we're going to follow. Canary. Okay. Alrighty. What do you got for us today, Baildung? Okay, so this article is the introduction to Jedis, a client library in Java. Sorry, making this a bit bigger and this a bit smaller. Popular in-memory data structure store that can persist on disk as well. It's driven by a key store-based data structure to persist data that can be used as a database, cache, message broker, etc. First, we're going to explain which kind of situations Jedis is useful and what it's about. Oh, that's an ad. Various data structures, explain transactions, pipelining, and the pub sub feature. Okay, cool. This is exactly what I want. So why Jedis? So Redis lists the most well-known client libraries on their official sites, blah, 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 blah. So they add some improvements on top of just the native Redis syntax, seems. That's fine. So here's the dependencies that you need. And just to install, you don't really install, you just install either run a Docker image and start a container that's got it installed, and then you just connect to it using the notation here. And then if you're doing it on localhost, then it's 127.0.0.1. And 6379 is the default port. So that's why I use 6379. So moving on, the default constructor will work just fine unless you have started the service on non-default port or remote machine. I'd actually never even tried it with not. Let's try that real quick. Will this work? Oh, cool. All right. So you don't even need to put anything in there. That's good to know. Strings. Strings are the most basic kind of Redis file, useful for when you need to persist simple key value data types. So jedis.sets. So let's just try some of this stuff. What did I just delete? Oh. Let's see what's going on here. So we're setting this thing, and then now we want to get this back, right? Jedis.get. Don't mind me, I'm just doing some shortcut magic here. So that should give us back the population here. See if that works. It does. Okay, so that's cool. So just namespacing here, events being the first component. So it's actually, this doesn't make sense. It shouldn't be events anymore. It should be kind of city, right? Why do we have events here? Anyways, 32 billion, I guess it would be. And so we're getting the value back, and then we're reading it out and just printing out the print line. The variable blah, blah, will hold the value, blah, blah, coupled with expiration support. Discussed later. It can work as lightning fast and simple to use cache layer for HTTP requests received at your web application and other caching requirements. So that's interesting. You can like cache sessions and stuff, and maybe cache HTTP requests and responses if you have things that are never really going to change or we're not going to change very often. So that's useful. Okay, so Redis lists. So this was strings, right? Just going to comment stuff out as I go. And then we're doing lists now, right? Redis lists are simply lists of strings sorted by insertion order. Okay, that's cool. So they maintain order. That's nice. Make an ideal tool to implement, for instance, message queues. Okay, so right pop. Okay, this makes sense. So left to right. So 1, 2, 3, 4, 5. So right pop would be, I guess if you're looking at this, right pop would be here. So it would take that value off, and left pop would take this value off. So it gets constant time lookup for left and right pops. I'm not going to go through this. Actually, why not? Let's just see what it does. What does it actually return? Whoa. Oh no. Please stop. Returns a string. Oh, it returns, okay, pop, of course. It returns you thing the back that you're popping off. So this should return second task, right? Actually, hold on, I just want to do something for later. Store this in my register because I'm going to be using it a lot. So this should return second task if this is working. Left push. What? You're pushing from the left. Left, right. You're popping off the top? Okay. I guess it's pushing down. So this is more like stack, right? So when you pop off, you're popping off the top with rpop. And that's giving us first task back. Interesting. Okay. Sets. Comment this stuff out. Redis sets are an unordered collection of strings that come in handy when you want to exclude repeated members. Right, so this is pretty obvious. It's only going to return nickname 1, nickname 2. I'm actually going to skip a few of these. Actually, maybe not. It's probably a bad idea. Let's just do these one by one. Doing our homework, guys. So what does this do? So this gives you the members. Okay, and you can test membership with this guy. That's neat. See, now it's useful. So we're going to print out the nicknames, and Boolean exists. Now we're going to do the test for membership. Oops. Is member. Oh, S is member. Set is member. That's right. Okay. And then we're searching for nickname 1. Oops. Nickname 1. Oh, you guys probably can't see this. Shoot. Oh, this is probably so annoying for you guys. Hold on. Let me switch spots here. There we go. And I'll keep the I'll keep the text up here in this section that I'm reading. That should be a little better. And then we're just going to print out exists. Okay. So this should tell us that, should give us the list. Okay, got it. So you can see here that we added nickname 1 twice, but it's only present once in the list. And then you can test for membership using the jedis.essays member function, which gives you the ability to see that nickname number 1 is in the nicknames key or nickname set. So that's neat. Comment that. Hashes. Okay. What number I'm on? 4. So what are we doing? So for user 1, for the name field of user 1, I want it to be Peter. Right? That's what this is saying. And for the job field, I want it to be equal to politician. So what should this return? Pop quiz, user 1 name. Hopefully the answer is clear. Returns Peter, or at least it should. As far as that in the chat, it says, it looks like lpush, lpop, rpop acts like a queue, but lpop should act like stack. Yeah, that is what it seems like. I kind of need to go and look at that and play with it a little bit more later on. So let's take this and just verify that it works how we would expect. So we're adding to the hash set. This should return Peter if this works in a sane way. Let's print this out, name. And then what is this guy doing? Oh, okay, so you can get, oh, this is great. This is exactly what I was wondering about when I watched the video. Because here you're setting multiple different fields of this object, right? Oh, this makes so much more sense now. So for user 1, you're setting the name and the job to Peter and politician respectively. But now you can grab all of them all at once, both the name and job keys and values by using hgetAll on user 1. So that's neat. So you get the map back. Oh, this is sweet. This is pretty cool. So I'm just going to print the map now. And this should have name to Peter, job to politician, right? So let's run this. Okay, hold on. What's the first thing I did? So I'm getting name, so this should return Peter, right? So name should be Peter. Okay, good. And then we're doing hgetAll for user 1, which should return us back this guy and this guy, and it does. Beautiful. Okay, this is awesome. Write a comment to myself. This is sweet. Okay, sorted sets. Oh, so this is the interesting one that I wanted to try when he was talking about it. Five sorted sets. So how does it work? Sorted sets are like a set where each member has an associated ranking that's used for sorting. Interesting. Okay, so this is a whole bunch of code. I just want to go down to what he said down here. So the variable player will hold the value player3. Player will hold the value because we are retrieving the top one player and he's the one with the highest score. Hold on, let's read all this again. So we're creating a map and then we're putting 3 things in the map. Player 1 has 3,000. Player 2 has 1,500. Player 3 has 8,200. So player 3 has the highest, player 2 has the lowest, and player 1 is in the middle. And then we're saying for every value, if you've never looked at Java map iteration, what this is saying is that for the map scores, for every key Now you have a reference. So it's going to iterate over each of these lines. So line 1, line 2, line 3, right? And now it's saying for every score, so it's going to get 3,000 the first time it runs over if it's parsing this key value combination. You're going to add using Jedis z add the key, which is in the first iteration, it would be player 1, and the value. And what are they saying? So you add the key, you add the value, and you do player score dot get key. It's writing the key twice. Is that what he's saying here? Seems like it. Anyways, let's try this and see what happens. Jesus. Killing me, Smalls. All right. So now he's doing this. Whoa. Usage of API documented as at. What are you even talking about? I think this is wrong. This doesn't even work. What is he doing? Hold on. Redis Ziad. Something's weird here. Either he's wrong or I don't understand, which both are equally possible. Oh. So you give the name of the set, you give the key. Wait, is that right? Accessible to elements, res version 1, it was possible to add or update a single member per call. So for each, we're adding the key. What is key here? There is no key. Hey, yeah, come. Oh, thanks. So yeah, something's obviously wrong here. Let me try to rewrite this. So scores dots for, is that what it's complaining about? No, well, we need entry set, of course. For each. And it finds all usages of methods that have since tag in their documentation. I think it's complaining maybe it doesn't like for each anymore. I'm not sure why that's going that way. Anyways. P dot get key. So I think this is right now. And then we want P dot get value. And then P dot get key again. Is that what's going on here? Something's wrong. Language level 5. Oh, do I have the wrong JDK set up? It's not going to help. Let me just try it without doing this entry set nonsense. Scores. Oh. Wait a second. The key being the name of whatever the hash map is in Redis. Okay, so hold on. This should be like players, right? This should be 3,000. And this should be player 1. So now we're saying, Jesus, add player 1 with score 3000 to player's hash map. There we go. Okay, this is looking better. I don't know why he even put this. This is just so confusing. This first part up here. Like, why are you using a map here? Just made your life so much more complicated. So players, and now we're going to say player 2 is that's, and then player 3 is 8200. Oh, these are doubles, floats rather. Okay, and now so we're adding them all. Player 1, player 2, player 3. Okay, so now they're all there, right? So what did he say next? Let's actually just run this and see if this works. I just want to know. Nice. Actually, so the interesting part is we can just go back over here and just do get players. And this should give us back the whole hash map, right? Oh. You can't use get. Oh, I think you can use hget. Wasn't it like hget all or something? We saw it, right? Hget all. Hget all players. Is this going to work? Oh. I want to know now. What's the command? Oh, I'm out of the shell. That's why. Dirt. Huh. Operation against a key holding the wrong kind of value. Returns all fields and values of the hash stored at key. In the return value, every field name is followed by its value, so the length of the reply is twice the size of the hash. I thought that would have worked. Oh, this was just for sets. Okay, yeah, sorry. Interesting. So I guess it doesn't support hget all. Okay, that's fine. So let's try this. Reverse range, ranking 0, 1, iterator next. What does this do? Okay, player. So everything between 0 and 1, I think that is what he's saying. Ooh, no such element exception. Oh, I think this is supposed to be this, players. Because that's the key that I'm adding it to, of the sorted set. Got it. So it's giving us the one, the top one, right? Top player. The variable player will hold the value player 3 because we are retrieving the top one player and he is the one with the highest score. The rank variable will have a value of 1. Oh, okay. So this is cool. So say for instance you have an application and you want to know like at all times what are the top 10 users, right? You can use either the range to get that. Right, so what do you say? Ranking, top one player, he's the one with the highest score. Player hold the value, player 3. The top one player. Oh, okay. So the top one player starting at index 0. Is that what this means? That's what I'm assuming. The rank variable will have a value of 1 because player 1 is the second highest in the ranking, and the ranking is 0 based. That makes sense. Let's just try that. Actually, I want to look at this. String key, long start, long stop. Okay. So start at 0, end at 2. What is this going to do? Let's look this up real quick. zRevRange command is used to return the specified range of elements in the sorted set stored at key. The elements are considered to be ordered from the highest to lowest score. The descending order is used for elements with equal score. This doesn't really give me enough information. Key min max, blah, blah, blah. Used to return a specified range of... These ads are just getting out of control. Look at this. You're killing me here. Okay, I'm never coming back to this website again after this. Array reply, key min max. But this is returning just one string. I feel like there's something weird going on. Range, my city set with scores. I think I have to look at this a little bit more carefully later. Anyways, let's move back to the tutorial. So the rank, so he's getting the ranking of player 1. We know that player 1 has the second highest score, so he'll get ranking 1 back. So this should return 1 if we do the same thing. And this is what it should give us. Null pointer, nice. And of course we don't have anything at ranking because I forgot to rename things. All right, there we go. So that's working as it should. That's a relief. Let's get rid of this. What's next? Transactions. Okay, so this is another thing that I wanted to learn about. So this is cool. So we are on number 6, transactions. Transactions guarantee atomicity and thread safety operations, which means that requests from other clients will never be handled concurrently during Redis transactions. String friends prefix, strings user 1 ID, user 2 ID. Okay. So he's creating a transaction. He's adding these 2 guys to the set, and then he's executing. So, and this is happening in one shot. It's not 2 operations, it's 1. You can even make a transaction success dependent on a specific key by watching it right before you instantiate your transaction. Ooh, that's cool. So this is the thing that we were talking about before, or I was talking about. For the optimistic locking, if you guys remember the notes, what did I write down? I wrote down, watches allow you to show intent of a subsequent update. After you pull the data back, if you attempt to write to a watched key and it is changed, your transaction will fail. So this is like saying only perform this transaction if no one has touched it in between the time where I touched it, right? So if someone has touched it, it becomes dirty. Then the next time I try to write, if it's still dirty, then I can't succeed because you've polluted the key. So let's run through this. So we got to do some imports. And now I think, what did he say? You can even make a transaction success dependent on a specific key by watching it right before you instantiate your transaction. Okay. So let's do that. What is this key? Where's deleted coming from here? Right? Interesting. Let's run this. Actually, what's even going to happen if I run this? It's not going to output anything. So let's just do this in the terminal now. Get friends, this number. Oh God, 4352523. Oh, is it sget or something like that? No, there's a special command. It's not just get. I can't remember which one it is. Because you're getting it out of the set, right? Okay, that's fine. I want to know more about how this watch works, but it doesn't really give you a very good breakdown of what it's actually doing and why we're using the namespace deleted here. But anyways, that's something I can look at a little bit more later. Okay. If the value of that key changes before the transaction is executed, the transaction will not be completed successfully. So that's fine. That's kind of what optimistic locking is, so that's good. Pipelining. I don't know if I'm going to do all of these actually. I may skip some of them. When we have to send multiple commands, we can pack them together in one request and save connection overhead by using pipelines. Essentially, a network optimization. As long as the operations are mutually independent, we could take advantage of this technique. Excuse me. So we're sending a bunch of commands in batch is what this is saying. So we're not really doing anything special here, but we're just sending all these things in one shot. I'm not going to go through that. Okay, publish subscribe. So I did want to try this. So subscriber. Subscribe and listen to messages sent to a channel. Let me just get rid of that. And we're on transaction, PubSub. So subscriber, so we're creating a subscriber object and we're subscribing to channel. Oh, so this is like the topic. Channel and this is the topic. So if you're coming from AWS, we're creating an SNS topic right now. I'll just make a little note here. SNS topic with name channel. All right. We have overridden the onMessage method, but there are many more useful methods. So I guess when it receives a message, let's just say, let's do something, right? Let's just print something out. Received message on channel. Plus channel plus with message equals plus message, right? So that should print out receive message on channel and with message. Looks good to me. So now we want to publish to it. Then simply send messages to that same channel from the publisher's thread. All right, let's try it. Oh, you guys couldn't see that. This thing is in the way. Let me put myself on the top left. It's probably the best spot now. And I'll make myself smaller. Can I do that? Yeah. Okay. So let's paste that in. So now we're publishing test message, and so we should get a message back here on the other side if this all was set up correctly. Let's see it happen. Oh, did it say it was blocking? We've overridden the onMessage method, but there are many more useful methods. So I think you need to like do this in a separate thread. Okay, hold on. Where is run again? Oh. Okay, so it seems like you can't test this. You need to have them both run in different processes. But this kind of gives you the idea of what's happening. So you can spread information out, communicate with one another fairly easily, and write some methods that respond to data changing. You'll need to unsubscribe from Jedis pub sub explicitly. We've overridden the onMessage method, but there are many more useful methods. Okay, well, wish I could have tried that, but no problem. It's important to know that the way we've been dealing with our Jedis instance is naive. In a real-world scenario, you do not want to use a single instance in a multi-threaded environment, as a single instance is not thread safe, right? Luckily enough, we can easily create a pool of connections to use Redis for us to reuse on demand, a pool that is thread safe and reliable as long as you return the resource to the pool when you're done with it. If you don't know what resource pooling is, it's just the idea that basically what they said is instead of establishing a new connection for every request, you just use a connection from a pool and you get a connection on a lease and then you get to use it and then you just give it back once you're done. Or if you don't heartbeat anymore, then you're considered orphaned and then they take the connection away from you. That's how these are generally built. So we build a pool config, blah, 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 blah. So you're just setting up some configuration here. And this seems like it's just a one-time thing that you need to set up as part of like your config, as part of your app. But yeah, this would probably just happen if you're using Java, like your app build or something like that, or Spring, or Google Juice or Dagger, all those guys. Since the pool instance is thread safe, you can store it somewhere statically, but you should take care of destroying the pool to avoid leaks when the application is being shut down. Okay. Then you can use the pool. Oh, that's cool. So then you just get a thread or get a connection from the pool using this whenever you want to use Jedis, and then you just do what you need to do. You probably need some finally here to give it back once you're done though. We use the Java with try with resources statement to avoid having to manually close the Jedis instance. But you cannot use this statement. You can also close the resource manually in the finally clause. That's exactly what I just said. Make sure you use a pool like we have described in your application if you do not want to face nasty multi-threading issues. Good call. You can obviously play with the pool configuration parameters to adapt it to the best setup in your system. All right. Redis cluster provides an easy scalability and high availability. We encourage you to read their official specification if you're not familiar with it. We will not cover Redis cluster setup since that is a bit out of scope. Okay. Powerful feature. Oh, that's interesting. You can't perform transactions on Redis clusters. That's a huge bummer. I wouldn't even advertise that you can do transactions then, because that's just crazy. Well, I guess if you're hosting a single instance of Redis, then you can use transactions, but it's probably a small minority of you. Transactions are disabled because in a cluster environment, keys will be persisted across multiple instances. Operation atomicity and thread safety cannot be guaranteed for operations that involve command execution in different instances. Some advanced key creation strategies will ensure the data is interesting for you. What? In theory, that should enable you to perform transactions. So they're saying here the workaround is for you to store your data in such a way so that the data that's part of the same object always lives on the same partition, so that you don't need to worry about it being spread across multiple nodes in your cluster. If all of the data is on the same node, then apparently the argument is you can still make transactions. Conclusion, the vast majority of the features from Redis are already available in Jedis, and its development moves forward at a good pace. It gives you an ability to integrate in-memory storage into your application with very little hassle. Just don't forget to set up connection pooling. Cool. Okay. That was pretty cool. I think I learned a lot. I just wanted to add some more notes here. So it supports, what else did I learn? Supports connection pooling, should be used in multi-threaded. Why am I doing this? Environments. What else? Oh, the cluster and transactions. Clusters do not support transactions unless all the data is on the same partition. Oh, so transactions or piping. Okay. So that's 1, 2, 3. Third one, pub sub is blocking. Pub was blocking, right? No, subscribe was blocking. Subscribe is blocking. Can't be. You have to publish on a different thread is what I'm trying to say. Publish can only occur on a different thread. Okay. Anything else I missed? Publisher, subscriber. Oh, just a note of pipelining. Pipelining is a batching technique used for optimization. Kind of like a batch save in Dynamo. Oh yeah, the watch stuff, right? So watch, watch before instantiating transaction to use optimistic locking. So again, if you do the watch here on friend's user ID, whatever you want to watch, and someone else modifies it in between the time that you are doing this and actually execute, the transaction will fail. The entire transaction will fail. So that was interesting. Sorted set. Oh, I want to write down that thing to look up. Sorted set alpop is weird. I need to look at that again. It may not be weird. I just could be dumb right now. Hashes. Oh, this was cool. Hashes get all. Hashes get all. ID gives back all fields and values related to that ID. Okay. Sets is members for membership. I don't think I need to write that. Lists are pop. Okay. Oh, it was lists. That's what it was. Lists. Oh, that's what it was. It was sorted sets where the thing was screwed up. So 8 sorted sets. Sorted sets. It was this zrev range. Look up zrev range. Here's an example. Okay. Strings, blah, blah, blah. Okay, I think I got it all here, guys. If you're interested in these notes, let me know, either in comments or chat. And I can share these with people. I can also share the code if people are interested. But I would encourage you, if you're trying to learn it as well, just try it yourself. It doesn't take very long. This was very easy. And then you get some real world experience. It's one thing to watch another person do it. It's another thing to do it yourself. So I feel like I learned a lot, so that was cool. I'm satisfied. I hope you guys learned something too. Yeah, so I don't have too much now. I think I'm going to head off, guys. Thanks for joining, Farzad. I'll talk to you tomorrow. And for everyone else, have a good night. Talk to you soon. Take care.